Alright, I'll say it. Ragdolls are funny. They're a staple of modern gaming. And they're also one of the trickiest things to program.
I like what I see.
It's difficult enough to set them up in single-player games, but getting them to work consistently in multiplayer sessions, that's when it gets even more complicated. That's why today, I'm going to show you how to create replicated ragdolls in Unreal Engine 5. Hello and welcome to Off the Grid with Jack Bittner. Today I'm going to be showing you how I created my replicated ragdoll system in Unreal Engine 5. I've seen some discussion surrounding this on Reddit and other forums, but I haven't seen a dedicated YouTube tutorial for this, so I decided to make my own video on the topic. Replicated ragdolls are a way to ensure that every player has the same experience when a character goes into a ragdoll state. Now you might assume, like I initially did, that UE5 handles all of this for you. When a physics asset moves in the world, doesn't it automatically update for everybody? Actually, it doesn't. At least, not on its own. Instead, what happens is, well, basically what happens in Season 2, Episode 1 of Rick and Morty. Now, I'm sorry for making a Rick and Morty reference in 2026, but this is what my mind kept going to when I was tinkering with UE5. In this episode, A Wrinkle in Time, Morty and Summer get into a disagreement over their responsibilities during one of Rick's experiments. This disagreement causes a rift in their timeline. This is because they
somehow created a feedback loop of uncertainty that split our reality into two equally possible impossibilities.
This is sort of what happens when you attempt to run ragdoll physics in multiplayer, at least the way most UE5 tutorials on YouTube would have you do it. In one possibility, the player's body is on the floor, while in the other, the body is standing up. Because of this, you need a way of replicating this behavior on both the client and the server. Enter replicated ragdolls. This isn't something I invented, but I haven't seen a good tutorial for this on here, so I figured I'd walk you through the system that I use in my game. In my game, inspired by Gonkville, my kids' book series, I wanted to introduce a stun mechanic in which players could bump into a wall or get hit with a spell and be rendered unconscious for a few seconds. Some games like Breath of the Wild or Tears of the Kingdom incorporate a similar mechanic. It's immersive and, let's not forget, hilarious. And very difficult to wire up. After days and days of trial, error, and research, this is the system that I came up with. So let's jump into UE5 here, and we're going to want to open up our BP third-person character, or whatever your third-person character blueprint is, and we're going to need to go through a few assets here and create some variables. So to start off, in the blueprint for your player character, you're going to want to create 5 variables here. First one's going to be called isRagdolling. It's a Boolean. Then isRagdollUp is Boolean. RootLock, or root location. Transform. IsStable, Boolean. CanRecover, Boolean. Pretty straightforward. Now let's go into the animation blueprint of your character, which you should already have one set up. And then we're going to create 2 variables here. We're going to create isRagdoll and root location. And these are just going to be informed by the third-person character blueprint that I have here. So I already have a cast to third-person character here, so this is just grabbing a bunch of variables from the player character, passing them to the animation blueprint at runtime. And we'll go over this logic and the logic in the third-person character in a second. But the next thing we need to do is make sure that you have a physics asset set up for your player character. There's lots of tutorials on creating a physics asset, so I'm not going to be covering that in this video, but that is something that you'll need to have. Without further ado, let's jump into the logic on the player side. Going back to my analogy about split timelines, you're going to need to think of everything in terms of a server version and a client version. So the first thing we're going to do is create 2 functions, or 2 events, excuse me, one called Enter Ragdoll Server and one called Enter Ragdoll Client. On Enter Ragdoll Server, we're going to set isRagdolling to true, then we're going to go through a sequence, and the first thing we're going to do is disable movement on the character movement. And then the second thing is a chain of physics events. So this is going to set collision enabled to no collision for the capsule component. Then we're going to set collision object type for the mesh to physics body. And then we're going to set collision enabled to query in physics, or collision enabled right here, also for the mesh. And then we're going to set simulate physics and make sure that this is ticked to true. And that is also for the mesh. Then the final thing we're going to do in this event is set root lock. So we're going to get the socket transform location of the pelvis. So where is the pelvis? Well, it is in your rig wherever this is. For me, I have named this bone root, so that's what I'm going to be using for this tutorial. So you want to get that. That's basically the root location or the root lock of your ragdoll. So we're going to get that socket transform, and we're going to set root lock to that. Then we're going to set a looping timer by event, and I have it set to 0.5 seconds. We'll worry about the return value later. This set timer by event is going to trigger a event called get ragdoll pose, which is going to set root lock same way we did it down here. It's going to get the physics linear velocity of the mesh, and then it's going to compare against this vector length. It's going to get the vector length of the physics linear velocity and see if it's less than 2. If it is, it's going to set is stable to true. So what the heck does all of this do? So the first thing we're doing is we're disabling the movement of the character movement. So we don't want the player to be able to move around while they're stunned. Now, once that's done, we're going to set the capsule component to not have collision. And why are we doing this? We're doing this so that the ragdoll can actually escape the capsule component, because otherwise it would glitch around in here because it's inside of it, inside of a solid object. Then all of this here, these 3 events, are just allowing the ragdoll to be influenced by physics, allowing the mesh to be influenced by physics. Then we're setting the initial location of the pelvis to root lock, or we're setting root lock with the pelvis location. And then we're setting a looping timer that pulls every 0.05 seconds and updates the location of root lock and does a final check of is stable. And we'll get into what that means in a little bit, but basically it's just checking to see how fast the ragdoll is moving. So now we want to create the counterpart to enter ragdoll server, and it's going to be, you guessed it, enter ragdoll client. So enter ragdoll client is going to be much simpler. We're basically just doing the same thing as the second part of the enter ragdoll server event. We're going to be setting no collision to capsule component, once again, so that the ragdoll can escape. We're going to be setting collision object type to physics body for mesh. We're going to be setting collision enabled to query and physics, also for mesh. And we're going to be setting all bodies below to simulate physics. Now you might be saying, Jack, I thought it's simulate physics, or set simulate physics. The reason we're not doing this is because the pelvis actually needs to be influenced by the server. So we're doing a local physics simulation on everything below the root, which means that everything that isn't the root, since that's the parent of the mesh, is going to be influenced by physics. So when the root's moving around, the left leg, the right leg, torso, head, left arm, right arm, all that's going to be flopping around, influenced by ragdoll physics, but not the pelvis itself. So now that we've done that, we're going to go over to the exit strategy. So we're going to do the exit ragdoll server first. This will set is ragdolling to false, and then it's going to trigger a complicated sequence of events. So the first thing it's going to do is run this custom function that I created called calc ragdoll pose. So let's click into that. Calc ragdoll pose is just getting the socket rotation of the pelvis root, splitting this into X, Y, and Z. We're grabbing the roll, the X axis, and then we're checking to see if this is less than 45 degrees. Then we're going to use this true-false Boolean value and return that. That's all it's doing. So then let's go back to the event graph, and this is going to influence the isRagdollUp variable that we created earlier. Now the second thing it's going to do is going to reverse all of the things we did earlier with the physics. It's actually the polar opposite of it. We're just setting everything back to normal. We're going to set collision enabled to query and physics for the capsule component. Then we're setting the collision object type for the mesh to pawn, so it can be controlled again. Then we're doing set collision enabled query only for mesh, and we're setting simulate physics to false. All of these 3 here are for the mesh. Then the third thing we're doing is we are clearing and invalidating the timer by handle. Now, where's the handle go? Let's follow it all the way back to this set timer by event that we created in the enter ragdoll server event. So this is just stopping this whole get ragdoll pose repeating event from happening. Then the last thing we're doing is we're setting the relative location and rotation back to what we have it. So in the viewport here, you can see I have -89 and 270 as the location and rotation on the yaw axis, or the Z axis. We're going to go back over to the event graph and use these exact two values here. And so we're just setting the mesh back to normal. Then we're going to set movement mode for character movement to falling, because we're going to be getting up and falling. Cool. Now that we have the enter ragdoll server created, let's go up here and create its counterpart, enter ragdoll client. So we're going to create another sequence of events. We're first going to save pose snapshot. So we're going to get the anim instance from the mesh here. That's going to feed into the get anim instance, and then we're going to save the pose snapshot, and we're going to title it ragdoll pose. Next, we're going to enter a branch. We're going to check if is ragdoll up is true, and then we're going to do one of two things. If it is true, we're going to be playing a get up from back animation that I've created. I'll show you what that looks like in a second, but basically this is just getting up from the ragdoll position from laying on your back. And then the other way around, if it's not, it's going to be getting up from front, so picking yourself up from front. Pretty simple here, just playing a montage, and that's connected to the skeletal mesh component, which is mesh. Then the third thing it does is, you guessed it, sets collision enabled for the capsule component to collision enabled query in physics, sets collision object type to pawn for the mesh, sets collision enabled to query only for the mesh, and sets simulate physics to false for the mesh. We're just putting it all back together. Now, there's another thing we need to do for both the enter and exit ragdoll state. We need to create a execute on all event. So what this does is it runs on what we call multicast. So one thing I left out is that for all of these events, you need to specify where it's running. So for the client events, you need to set replicates to not replicated. Whereas for the server, you need to set it to runs on server and reliable. That shows up here in the details panel. But for the exit ragdoll event, that's going to be a multicast, which means it runs on both client and server and all of the clients. So this is going to trigger exit ragdoll server and exit ragdoll client. It's pretty straightforward. We're also going to now go over to the enter ragdoll counterpart for this multicast. And this one is actually a little bit different. This one I'm calling stun because it is called when the player is stunned. This is going to trigger the enter ragdoll server and enter ragdoll client events. So let's set off the chain here. We got set can recover. We're going to be setting that to false. We're going to be, you can disregard this. This is just a game mechanic that I have. Enter ragdoll server and enter ragdoll client right back to back. Then we're going to set a timer by event. This is not going to be looping. This is just a delay. Set it for 0.5 seconds. And this event is going to be called set can recover. And we're going to set this to set can recover to true. So what this is basically does is this forces the player to be in a ragdoll state for at least 0.5 seconds. Because otherwise, if the is stable, it suddenly becomes true because the ragdoll just isn't moving that much. We don't want them to immediately get back up as soon as they get stunned. We want to force them to be stunned for at least 0.5 seconds. So that covers the entrance and the exit of the ragdoll state. Now we need to go over to the animation blueprint because this here is where we actually drive the physical animation. As I mentioned earlier, I have a cast to BP third-person character that runs on blueprint event update animation. A lot of animation blueprints have this. Mine's very messy, but it gets the job done. So we're going to drag off of this. I have a chain here setting all the variables here. But as third-person character, we're going to grab root lock. And we're going to split root lock so that we can access the location, rotation, and scale individually. We're not going to be using scale because we don't want the ragdoll to change scale. We're also going to get owning component and get the bone transform of root. And what we're going to do is then interpolate these. So for the location, we're going to use vinterp2. We're going to set root lock as the target for this, and get bone transform as the current. And then we're going to set the interp speed to 12. And what this is doing is basically just making up the difference between the snapshot positions. So as you may recall, every 0.05 seconds, root lock is updated. Root lock specifies the location and rotation of the pelvis, and so we want to interpolate smoothly between those two poses. We don't want to abruptly shift forward in time every 0.05 seconds. It might seem like a very small amount of time, but you'll notice it, especially at high FPS. So we're going to take the interpolated values of both of these, and we're going to set root location to the result. And we can leave scale as 1, 1, 1. Let's go over to the anim graph. So this is where we're actually going to be setting the pose of the player mesh. We're going to create a state machine called ragdoll, and we'll get into what that looks like on the inside in a second. Then we're going to modify this by converting it to component, so location, local to component. And we're going to transform / modify bone here with root lock, root location. That is our animation blueprint equivalent of that. So we're going to take location, move that into the transform, and we're going to take rotation and move that into there. For this, we need to go through this and make sure that we have replace existing set for the translation mode, and for the translation space, we want to set that to world space because that is how we're capturing the pose. And then we want to set rotation mode to replace existing and rotation space to world space. Once again, we can leave scale untouched and set that to ignore. Then we're going to take the output of this and convert it back to local. So component to local right here. Then we're going to blend the poses by bool. This is very important here because this variable determines whether the player is in the ragdoll state or not. So if false, we're just going to have all our other pose logic, whatever you have going on, that's going to be connected to false. But if it's true, then we're going to have that connected to the local that we just generated here. And then we'll feed that into the output pose. Now let's go and look at the ragdoll state machine here. This is very important. We want to double click on that and look at our entry into tumble state. This is going to just be a fall sequence that I have. It's just a falling animation. And then we will have the snapshot, which would be shifting between the two. Snapshot is going to be an empty animation pose because this is going to be filled up by the snapshot. And we'll set tumble to snapshot to is not ragdoll, and will be the opposite for exiting the snapshot state. And there you have it. And that is our complete ragdoll system. So if you're doing testing, you will need to create a way to trigger stun in some way. You might have it set to like getting hit by a punch or a bullet or something like that. For me, I currently have it set to a series of custom logic events that check if a player is heading into a wall quickly. And I can show you what that looks like, but effectively, it just triggers this. If you want to just mess around, what you can do is you can create a, use like F key, for example. So when F is pressed, you can enter the stun state and the character will ragdoll. That's not what we're trying to do here today. I already have my logic set up for entering the ragdoll state. So with that out of the way, let's do some ragdolling. Let's hit compile. I'm going to minimize this and then click play. So you see I've got my player character here. I'm going to run at the wall, jump, and there we go. I ragdoll, and this is on the client and server. Just to prove that it works in multiplayer, I'm going to open up a netplay session. So let's go to here, and we want to set the number of players to 2, and set net mode to play as client. Then we'll do new editor window. This will open up two sessions, and I'll go ragdoll in front of player 2 over here. Whoops, didn't hit it with enough speed. And there you can see, we're ragdolling in 2 places at once. And it plays the get up animation once I get back up. And that's how I solved the client-server issue with ragdolls. I hope you find this system as useful as I found it. If you did, please leave a like and a comment. And if you feel so inclined, I welcome you to check out my Gonkville website. I have a blog on there for tracking updates to my game. I also have a social media for Gonkville, so I'll leave a link to those as well. Thank you for watching my video, and may God bless you.